Okay, we're going to get into factoring trinomials. A trinomial is a term that has, or a polynomial that has three terms. So an equation with three terms, okay? Specifically, the highest power is going to be squared. So it means we're dealing, if it's squared, some graph, it's some type of quadratic, okay? And we want to work on getting into factored form. There's a couple ways we can do this. One of the ways we're going to work with is the way I most commonly do it, and then we'll do a way called decomposition after. That's what it's called. Okay. Now, what I want you to get used to looking at is a lot of times they write an equation like this. Y equals, and they'll have x squared x. So they'll have ax squared plus bx plus c. And they'll write a trinomial this way so that you get used to referring to these coefficients or these numbers by these letters. Okay. So in our equation, what would our a number be?
16.
That's right, 16. What would our b be?
40.
And c?
25.
Excellent. Good. So that's really important to be able to distinguish which is which in each question. Now, in the method we're going to do, what we do is we find all of the factors of our a. Okay. So we're going to look for the factors of 16. So I'm actually going to rewrite this below in a different color, though. So we have 16. And then we have x squared. Oh, sorry. In the question, it's p. And it doesn't matter what the variable is, right? So p squared. And we have plus 40p and plus 25. Good. So we've distinguished them with our colors. We're going to find all the factors of 16. So, and what we're going to do is we're going to write them in columns to help us organize this. Okay? So can you give me a set of factors of 16, two numbers that would multiply to 16?
1 and 6.
Okay, 1 and 16. Yeah,
yeah,
that's okay. I know what you meant. Okay, and what I'm going to do is I'm just going to put that, I'm going to put it in a red column. In a column. Okay. But there's more than that. Yeah. What else is there?
4 and 4?
Yeah, 4 and 4 work. There's actually another set too. You think about it while I got the color.
8 and 2?
That's right, and 8 and 2 is another one. So I'm just going to set up the column for that. And those are the three sets. Okay? Now you don't have to set them up the way I have, but this helps us organize stuff. So I've set up all the factors. Along with that, I need all the factors of our C term. Okay, so what is one set of factors for 25?
1 and 25.
Excellent. Okay, and I'm going to do the exact same idea. I'm going to set them up in a column. Can you think of another set while we're doing that?
5 and 5.
That's right. So I'll set up the second column. Okay, now the reason I've gone about doing it this way is because I want to help us organize for what we're about to do next. I set these columns up because next what I do is I'm going to need to find the product of two numbers that add up to our b value, okay? And in this case, that's 40. So you might think, okay, what do I mean by that? What I mean is I'm going to take one column and try multiplying it by another column to see if I get two numbers that add to 40.
Okay.
Okay, and this is why I've set it up this way. So our first column we'll try. 1 times 1 gives us
1.
Yeah. And now this one's a really hard one, so you might want to get your calculator out. I don't know it off the top of my head. 16 times 25, and I'll put in our calculator. 16 times 25, 400. Okay, so we have the numbers 1 and 400. Can I add or subtract 1 and 400 to make 40?
1 and 400?
Yeah. I
No.
cannot add them to that. So that doesn't work. Okay, but we should work across also. Let's try 16 times 1. And 1 times 25. 16 times 1 gives us 16, and 1 times 25 gives us 25. 16 and 25, can I add or subtract those to get 40?
No.
No. So we know that these two columns together didn't work. Okay. We're going to repeat this process until we find a pairing. So, next set. 16 and 5, I'm going to tell you that gives us 80, and 1 and 5 is 5. 80 and 5 make 40?
No.
No. And then if I go across, I get the exact same numbers. 80 and 5. Can I get 40 out of those?
No.
No. Okay, so what we've just discovered, and this is how we go through the process of elimination, that my first set, 1 and 16, are not a pair of factors we're going to use. It didn't work. So we go to the next one, 4 and 4. And we repeat this process. 4 by 1 and 4 by 25. That actually gives us 101. Any pairing of those work?
No.
No. And if we go across, because the numbers are still 4, we got 101. So that doesn't work. Let's go to the next one. 4 and 5 and 4 and 5. what do we get? 20, 20. Do those work?
Yeah.
Okay. So now I'm going to permanently draw those lines in. We know that 4 times 5 and 4 times 5 worked. We got 20 and 20. Good. So those are the numbers we're going to be using. Now this is really important to us. Okay. So now these numbers are all the same, so it happened to work out this way. When we go to put it in factors form, we have y is equal to, okay, and we'll have 2 sets of brackets. Our red terms will be the first terms in each brackets, and our green columns will be the second terms in each set of brackets. Okay. Now in this case, we have 4, and we should attach the p to it. So there should be a p here. So 4 and 4p, they both happen to be the same. And here we had 5 and 5. Okay, so that's our factored form. We took the numbers in the columns and we plugged them in. We took the 2 4s, they were the first terms, and we took the 2 5s, they were the second terms. And it just so happens, this happens to be a special case. Both of the brackets are the same,
Yeah.
so we can represent this by actually writing 4p plus 5 squared. I don't have to rewrite that twice. Okay, so there's one way of going about doing this.